Okay, in the last video we discussed central force. Okay, we've given few examples like gravitational force is an example of central force. Electrostatic force of attraction is also a kind of central force, and spring force. And then we discuss a few properties. The first property was that um, the central force is conservative. That is, the total energy of the system in a central force field is constant. The second property was the total momentum of the system in a central force field is also conservative or constant. Okay, and the third and the last property was that the path of the particle is a plane curve. What it means? It means that a body in a central force field is always moving in a two-dimensional plane. Okay, so if a body move in a 3D plane, suppose we have a Cartesian coordinate system x, y and z. If the particle is moving in a three-dimensional plane, suppose we have a particle which is moving along this curve in a three-dimensional path, then its position vector at any point A or B can be written as r is equal to xi plus yj plus zk. So from this we can say that the position vector is a function of x, y and z. But if suppose we have a particle which is moving in a two-dimensional plane, okay, in a plane curve, at time t the particle is at point A and its position vector is r. After time t plus delta t, after a small interval of time, the particle will move to another point, let's say point B, and its position vector will be r plus delta r. So time here is t plus delta t. Here the time is t. So at this point the coordinates of the particle is x, y, and at this point, at point B, the coordinates of the particles are x plus delta x and y plus delta y. So it means that the particle position at any point is a function of two coordinates x and y, r and x and y. Now there is another coordinate system which is called plane polar coordinate. And this coordinate system, we can represent the position vector as a function of two quantities. One is r and the other is theta. What are the meaning of these two coordinates? Suppose now in this coordinate system x and y, we assign the unit vector along each axis. Along x-axis the unit vector is I, and along y-axis the unit vector is j. Now suppose we are moving to the plane polar coordinate system, okay, then the situation will be like this. We have the Cartesian coordinate system x and y, along x the unit vector is I, along y the unit vector is j. Now the particle is moving in this plane curve, and suppose that at time t the particle is at point A, and after some time the particle moves to point B. Here the position vector is r, and here the position vector is r plus delta r. Delta means a small change in position vector. Now this position vector initially at point A making an angle theta with x-axis. So at this point the particle can be represented by two coordinates, which are r, the distance from origin to point A, and theta. Theta is the angle which the position vector making with x-axis. At this point, if the particle move from A to B, it will create a small angle also, which we represented by delta theta. So initially the angle was theta, and it's create a small angle which is delta theta. So at this point the particle is represented by two coordinates, r plus delta r and theta plus delta theta. So it means that the particle at any point in plane polar coordinates can be represented like this. The position vector of the particle is a function of two quantities, one is r and one is theta. What is r? R is the distance from origin to the particle, from origin to the particle position. Here the particle is at point A, so distance from origin to this point A to this particle is r, and theta is the angle makes by this position vector r with x-axis. Now in Cartesian coordinates, we assign the unit vector I along x-axis and j along y-axis. Now in plane polar coordinate system, we have also two unit vector. One is r and the other is theta. Like in Cartesian coordinate system, the particle is represented by two coordinate system, x and y. While in plane polar coordinate, we need two coordinate system which are r and theta. This is in Cartesian coordinate system, this is in plane polar coordinate system. Now in Cartesian coordinate system, we assign two unit vectors I and j, I along x-axis and j along z-axis. Similarly, in plane polar coordinate system, we have also two unit vector, one is r and one is theta. R is the unit vector along the direction of r. So the direction of r is here, so the unit vector r is this one. Similarly, theta cap is the unit vector along the direction of angle theta So the angle direction is this one, so it means that the theta unit vector is this one. This is theta unit vector because it's represent the direction of this angle and r represent the direction of this distance. Similarly, here the unit vector is r plus delta r, and the unit vector along the angle is this one, theta plus delta theta. Now, in Cartesian coordinate system, the unit vector I and j are constant because they are always along x-axis and y-axis. While in plane polar coordinate system, r and theta varies with time. How? If the particle is at point A, the direction of position vector is this one. Okay, but at point B, the direction of the position vector changes from this to this. Like here, the direction is this one at point A, r, while at point B, the direction changes like this, r plus delta r. So it changes with time from point to point. Similarly, if we look at the position vector, the unit vector theta, here the direction of this theta at point A is this one, theta, unit vector theta. But at point B, the direction is this one. This is theta plus del theta. So it means that if we differentiate this position vector in Cartesian coordinate system di over dt with respect to time, it doesn't change, so its value will be 0. Similarly, it's dj over dt because they are constant. But if we look at here, dr, the rate of change of unit vector r with respect to time is not equal to 0 because it changes with time. Similarly, d theta divided by dt is not equal to 0. Now, if we calculate the velocity, which we represent by r dot, which is equal to dr over dt. If we calculate the acceleration, which is represented by r double dot, which is equal to d square r over dt. Then in Cartesian coordinate system, we have a simple relation which is dr over dt and d square r over dt. But in plane polar coordinate system, this relation contains some extra terms. And the extra terms comes from these two values. And in the next video I will explain the inclusion of this extra term in this velocity factor and in this acceleration equation.